No. What is a contour diagram, everybody? What's a contour diagram?
It's like the cross sections.
Cross sections at certain output values, right?
Yeah.
Cross sections at certain output values. So for example, let's look at this one contour right here. See that one right there? So that's at -4, right? So that one of these functions looks like that when it equals -4. When it equals -4. So one of them looks like that when it equals -4. What shape is that? Yeah, it's a circle, right? It's a circle. So which ones of these are going to be circles? Which ones are not going to be circles? You have to do this by investigation. You have to do this by investigation. So, for example, are these in the proper form right here to be written as circles? Well, what do you need to do? You need to remember some basic math here, everybody. Or, excuse me, I don't use that word lightly, but you're in BC Calculus, so you should be able to complete the square. Exactly. Exactly. So you complete the square on all of those, right? And then what do you end up with? You end up with x minus something squared plus y minus, plus something squared plus a constant, right? And that'll tell you what the center of the circle is. So for example, what quadrant? Oh, we're in the first quadrant here. So then you have to look at what happens as you get different output values. You just have to investigate this piece by piece. There's no one way to do this, and I'm not going to do. If you look in I gave you the answer key, didn't I? Mm-hmm. The answer key talks about, it's like paragraphs of text for a few of them, but it gives you ideas of what to do. Take a look at that, but there's no one way to do this. You have to do it by investigation. You have to do it by investigation. Some of these are going to be like, so for example, is this going to be a circle right there when this equals, let's say, -4? If you square both sides. Oh, wait a minute. Can you ever get a -4 on that one?
No.
No. So you can start eliminating. Do you see what I mean, everybody? But the point is, if that was equal to 2, for example, could that equal 2? Sure. Square both sides. Is that a circle? X minus 1 squared plus y minus 2 squared equals 4. Is that a circle? Yes. But what happens if you're subtracting? What happens if it was x minus 1 squared minus y minus 2 squared? Would that be a circle? No, it's a hyperbolic paraboloid, right? And which ones are those? Which ones are the paraboloids? 3 and 4. So you have to do this by investigation. Complete the square, find where the pluses and minuses are. Don't lose them. Be very careful. There's no one way to do them. Y is going up and down, and x is going side to side. So you're trying to do a contour diagram where y is going up and down and x is going side to side, like this. So yes, it's challenging. Why is it challenging? Well, you look at it, you're like, oh, well, why? Okay, you need to, basically, you want to be able to do this. You want to be able to like look at it like this, right? Where y is going up away from you. You want to be, your head is floating here, and you're looking down on this, where you're looking straight down on the origin. So what is this going to look like? You have to do cross-section. So for example, does it go through the origin?
Yes.
How many times does this cross the origin? Once. It crosses it right there. It doesn't double back. You know it's right there, correct?
And then it's...
Yeah, and then what happens? It goes up. So it's going down this way, right? And it's also going down that way. Do you agree with what I just put up there?
Yes.
Because it's going below the axis right there, and it's going below behind, correct? Everybody sees that? Everybody kind of got that, right? Okay. Nice. So what do you do here? Where does it cross the XY plane? What does it look like when it crosses the XY plane? It's a line when it crosses the XY plane. So what do you end up with? You end up with something like this, right? So that's where it crosses the XY plane. That's when Z is 0. It's going out like there. You see that? That's Z is 0. But what happens if it's going down? What do the contours look like? Well, you have an example right here. What are they? Oh, look. They look like that. So what are they? On each of these regions is going to look similar, but the values are going to be different, right? They go down in 2 directions and what? Up in the other. So what do you end up with? You end up with contours that look like this, right? And what shapes are those? What shapes are those? Hyperbolas or parabolas? Yeah, I don't remember my conic sections, so you guys maybe have a better idea than I do. But what does it look exactly the same over here? Yeah, it does. But what's the difference? These are going down and these are going what? Up. I'm curious as to that if you pick what? You pick z values. You pick z values, right? Now since it just says with 4 contours, right? It doesn't say anything about them. It's just 4 contours. So pick nice ones, right? So when you graph this, and I can almost draw a straight line. I'm very sorry. What are the contours going to look like? Well, pick some values here. I don't know, like, how about 3 equals 3x plus 3y, and 6 equals 3x plus 3y, and 9 equals, why am I picking those values? 12 equals 3x plus 3y. So what do you get there? X plus y equals 1?
Yeah.
What is, oh, that's here, and what is that? That's that, right? That's the first contour?
Like 2, 2.
Correct? So then what's the next one? X plus y is equal to?
2.
To 2, right? So what are these going to be?
Just lines with the slope of 1 and then
Slope of 1? Are these a slope of 1?
negative lines.
Yeah. So, and again, what if I ask you, what kind of surface is this? Those contours are evenly spaced and they are parallel and they are lines.
Yeah.
It's a plane. Yep, it's a plane. Yeah, there you go. There it is. Yay, exciting. So when you're asked to draw contours and you're given a function, just pick output values. And since you can pick any output values you want, pick nice ones. Pick nice ones. Sound good? Okay. Yay, 31 word problems. Woo-hoo. I made a topo map of. Thank you. Find an equation for the plane containing the line in the xy plane where y equals 1 and the line in the xz plane where z equals 2. So a great thing to do first, maybe try to draw a sketch of what's going on. Try. So let's try to draw a sketch. The thing is, three-dimensional sketches, easy or hard? What do you think? They can be hard. I mean, everything is relative, but generally speaking, be real careful. So in the xy plane where y is 1, let's say y is 1 right there. So there's this line, right? That's y equals 1 in the xy plane. Sorry about the bend, but that's just how it is. And then it says, and the line in the xz plane where z is equal to 2. So that's in this plane, let's say z is equal to, z is xz plane, xz is equal to, so it's up here, right? You see that? So that z is equal to 2. So what is this plane going to look like? It's going to look like this, right? It's a tilt. It's extending infinitely like that, but it's slanted. So do you see the plane at least? How many points do you need to write the equation of a plane? How many points do you need? Need 3 points. We are limited, though, in that we can't just pick any 3 points because we don't have all the tools yet. You'll get them real soon. We need 2 points that have the same what and 2 points that have the same what? Y values and x values. So you need like a triangle of sorts. So you have to pick your points. So
Like a right triangle.
you want to find some sort of like right triangle, but they have to be on the plane, right? So there are 2 points that I've labeled already, right? How about this point and this point? Let's start with those two. What's this point right there? 0, 0, what? 2. And what's that point right there? 0, 1, 0, right? So now we need to pick a point where y stays the same on this one. Oh, wait, but then we need one where x stays the same too, right?
Yes. Oh, well, we have one where these two x stays the same.
These two, oh, we already have the x stays the same. So we just need to pick one where y stays the same, right? Where y stays the same?
So we could do like -1.
Yeah, anything, look, we're one where y stays the same, right? So we could pick anything along here, right? Or anything along there, right? Because y would stay the same. Do you agree with that, everybody? So let's keep down low. Let's go 1 back right here. Let's go to that point. Let's say that's 1 back. What point is that going to be? -1, comma. What's the y value? 1, and what's the z value?
0.
So how many points do we have? 1, 2, and 3. Do you agree that those 3 points are on that plane? Find me the equation of that plane. Actually, before you do that, can someone tell me what the general equation is for a plane that we're using? Z minus
C
equals, remember what letter? M.
x minus plus n times y minus.
And do you remember what M is? Partial.
dz over dx.
Don't say D. It's partial Z, partial X, and N is equal to partial. I keep on writing Y. It's not Y. It's partial Z, partial Y. And what does this mean? If we're doing the change with regard to X, what's constant on that one? So Y is constant. And what about the other one? X is constant. So I'll give you that. Now find me the equation of that plane and write it in the nice form, which was what? Remember? z equals ax plus by plus c. So simplify it. Okay. Not as important this time because we picked the same points. But if I let you pick any 3 points that work, I would want you to do this. M value. 0. N value 0. Okay. And what'd you get for n value?
Negative.
I think it's -2, right?
Yeah, I've got -2.
-2. It should kind of make sense because if you were on that plane and you only walked in the x direction, what would happen? If you were standing on that plane and you only walked in the x direction, z wouldn't change no matter where you started, right? So dz dx, partial z with respect to x is going to be 0. So what do you end up with? Z minus, oh, what point are you going to pick? Let's do, how about 0, 0, 2? Z minus 2 is equal to 0 times x minus 0 minus 2 times y minus 0. So what do you end up with? Z minus 2 is equal to -2y. So z is equal to -2y what? Yep, that's correct. And another way to see that, what's the equation of this line right here? If I connected that, see that segment right there? I'm drawing terribly now. But if I had that segment right there, that would have the equation z equals -2. Yeah, right? It would equal z is equal to -2y plus 2. But then it telescopes in and out because it's independent of x. Take that line, everybody. If you took this line and just slid it back and forth, what would you get? You would get the plane. Does that make kind of a little bit? Maybe?